This little voltage regulator cost me $11. I got it so that I could plug my fume extractor into it and I'd have an easy thing on my desk just to turn off and on. And I could use a dial to make it quieter, louder, stronger, more quiet. It worked really well. And then it stopped working. And the way it stopped working is it just went full power and that was it. And there are a couple of ways to regulate voltage. You could just run power through a big resistor. A variable resistor might be able to change the voltage, but you're going to burn that power up on the resistor. It's still going to get hot. Another way is to use a combination of electronics. For this little device, they used a combination of a triac and diac. As you can imagine, if you were to turn off and on the light switch many times, you can lower the overall power consumption of the light bulb. And that's really what these two devices do together. So they're both broken. I need to replace them, and here they are. New parts. This small blue device is called a diac. It's two diodes that are opposed to each other, and it allows just a constant, in this case, small amount of power, electricity to flow through it. This at a constant voltage. It will energize one of the pins on this triac. When it does, the other two pins will start to pass electricity. They'll start to allow power to flow. So if this device turns off and on, say 1,000 times in a second, it's like throwing a light switch 1,000 times a second, and this diac will turn off and on 1,000 times a second, effectively lowering the voltage. So you can imagine if you have a light bulb in your house, it turns off and on 60 times a second, 50 times a second in other parts of the world. And this constant turning off and on changes the properties of what is going on. For example, a motor that is turned off and on is not going to run as fast as a motor that is constantly on. A light that is turned off and on won't be as bright as a light that is, constantly on. And so these two devices together kind of regulate and control the voltage and then the devices at the end of them. In my case, my fume extractor will suck air at much more powerful or much weaker rates, depending on how I turn the dial. And that's controlled with these two devices here. Here's a fun and completely unrelated fact. Did you know that the University of Oxford is 900 years old? It started in 1096. That's quite old. To put that in perspective, the pyramid at Machu Picchu was constructed in 1450. That's like 600 years old. Oxford is 300 years older than the pyramids at Machu Picchu. It kind of throws my sense of history and timing off. Here's another interesting fact, although not quite as interesting as the age of Oxford and Machu Picchu's and pyramids. The Diac and Triac that I purchased to fix this device, this $15 voltage regulator, cost me almost $8 after it was shipped to me. I don't see how that's possible. These are far from the most expensive items that are part of this device. The creation of the device and shipping it out to me, it's just I don't see how a consumer can purchase all the items in it and build it with your own labor and not do it for something like 4 or 5 times the cost of the actual device. Blows my mind. Most people just use a normal toothbrush. They all say Oral-B or something on them. and they work just fine. But this little brush with really fine bristles can really get in between the components. And I gotta love using wick to remove the solder on a through hole. There's something so satisfying about a repair that is completed and working at the end.